All right, so we are looking at adding radical expressions. So if you look to the right, I've already written out parts of a radical expression. This is a little bit more extensive than it was in yesterday's diagram because we are adding what we call a coefficient, which is the big number. You see how I wrote the big two outside of the radical, and then in green, the little number that goes inside of that little check mark is what we call the index. The number that's inside of the radical, which is in blue. The blue is the radical, but the orange that's inside of it is called the radicand, and then that red too is an exponent. You won't always see all of these different components expressed, but then that's when we know that they are invisible numbers. Sorry for getting tongue tied. Invisible numbers that we use. All right. So now, in order to add radical expressions, we have to have two things. The radicand has to be the same. So this number that we have written in orange has to be the same. And then it also has to be the same index. Remember that when you have radical expression, the index, when it is not a number, right? When you do not see a number, it is an automatic two because this symbol is the square root. Square root is two. All right. So when you don't see a number, it is an automatic two. Okay. So let's look over here to the left. We have the same radicand because it's a five for both of them. And then we do have the same index because you see that there's a number missing in both of those places, which means that it is a two. Okay. So when we are adding radical expressions, we check to see if it has the same radicand. We check to see if we have the same index. And if we do, we are simply going to add the coefficient. Okay, we're going to add the coefficient, which is the large number that is outside, and we're going to keep the radicand and the index. So 7 plus 3 is 10. So then our answer would be 10 times the square root of 5. And that's it.